Section 4.3, solving systems by addition. We've solved systems by graphing, we've solved systems by the substitution method, and now we're going to solve them with the addition method. Okay, given the system, which variable, x or y, is easier to eliminate using the addition method? Okay, if we look at the x's, the numbers in front of the x's are not multiples of each other. But if we look at the y's, we see that 3 and 6, those would be easier to eliminate. So I'm going to say the y's would be easier to eliminate. We want to get the same number but the opposite sign in front of the y's. If I multiplied this number by -2, I would get a -6 in front of this y. So I'm going to multiply this entire equation by -2. That means I've got to multiply each term by -2. I'm going to get rid of those because it kind of gets messy if I don't. I'm going to leave the first equation alone, 7x plus 6y equals -2. And my new equation down here will give me -4x minus 6y equals -4. Now, when I add these two equations together, the y's are gone. 7x minus 4x is 3x, and 3x equals -2 minus 4 is -6. Dividing both sides by 3 leaves me with x equals -2. So I'm halfway there. X equals -2. Just like in the substitution method, we can now plug that x equals -2 into either one of these equations. I'm going to plug it here to the second one. So 2x, which is -2, plus 3y equals 2. -4 plus 3y equals 2. Add 4 to both sides. 3y equals 6. 2 plus 4 is 6. Divide both sides by 3. Y equals 2. So my solution, x equals -2, y equals 2. So the solution set is -2, 2. Question 2, solve the system using the addition method. Okay, let's go look at the numbers in front of the x's and the y's. Ooh, the numbers in front of the x's are already -5 and +5. I'm liking that. The numbers in front of the y's, yeah, not liking that much. So let's go just eliminate the x's right off the bat. -5x plus 5x, those are gone. 2y minus 5y is -3y. -42 plus 60 is 18. So -3y equals 18. Dividing both sides by -3, y equals -6. Y equals -6. I'm going to plug that in. Oh, let's see. Let's go to the second equation. So 5x minus 5y, which is -6, is supposed to equal 60. So 5x plus 30 equals 60. Subtracting 30 from both sides, I get 5x equals 30, because 60 minus 30 is 30. Dividing both sides by 5, I get x equals 30 divided by 5 is 6. So my solution, x equals 6, y equals -6. Always put the x first, x comma y. Question 3, solve the system using the addition method. Okay, I see that the numbers in front of the m, one's positive 1, the other one's negative 3. That one's okay. Let's see, I would have to multiply the top one by negative 3 to get that one to work. I'm going to go with multiplying this first equation by positive 3. Okay, here we go. 3 times m is 3m, plus 3 times 2n is 6n, equals 3 times negative 2 is negative 6. I'm going to leave the second equation completely alone. Negative 3m plus 6n equals negative 6. The m's are now eliminated. 6n plus 6n is 12n. Negative 6 minus 6 is negative 12. Divide both sides by 12. I get n equals negative 1. Okay, plugging n equal negative 1 into either one, I'm going to plug it into the first equation. So m plus 2n, which is negative 1, equals negative 2. M minus 2 equals negative 2. Adding 2 to both sides leaves me with m equals 0. So my solution, m is 0, n is negative 1. So I have 0, comma, negative 1. Okay, question 4. Solve the system using the addition method. They get a little tricky on you. See on this first, on the first equation, they have the s and the t on the same side of the equal sign, but not here on the second equation. So I need to add 2t to both sides. I will get negative 5s plus 2t equals negative 5. And I'm going to forget about this equation now. Now they're both in the same form. To eliminate the s's, negative 4, negative 5, I would have to multiply both equations by something. To eliminate the t's, 3 and 2, I'm going to have to eliminate or multiply both equations by something to eliminate the t's as well. I'm going to choose to do the t's because the numbers are a little smaller. So I need to multiply this one by 2 to get a positive 6t. To get a negative 6t down here, I need to multiply by negative 3. Negative 3 times 2 would be negative 6t. Okay, so here we go. Let's go multiply the top equation by 2. I would get negative 8s plus 6t equals 6. The bottom equation, negative 3 times negative 5s is 15s minus 6t equals 15. When I add these two equations together, the t's are gone. Negative 8s plus 15s is 7s. Let's go check that. Negative 8 plus 15 is 7, correct. So 7s equals 6 plus 15, which is 21. 7s equals 21. Dividing both sides by 7, I get s equals 21 divided by 7 is 3. S is 3. I'm going to plug that into my top equation. Negative 4 times s, which is 3, plus 3t equals 3. Negative 12 plus 3t equals 3. I need to add 12 to both sides. So 3t equals 15. 3 plus 12 is 15. Dividing both sides by 3, t equals 15 divided by 3 is 5. If I put them in alphabetical order, S comma T, S is 3, T is 5, so my solution set is 3 comma 5. Number 5, solve the system using the addition method. If I tried to eliminate my x's, I would need to multiply the first one by -2. If I try to eliminate my y's, I would have to multiply the first one by 3. 3 times 6 would be +18 and -18. I'm going to go with the x's. So let's multiply the top one by -2. I would get -6x minus 12y equals -2 times 26 is -52. Leaving the second equation completely alone, 6y minus 18y equals 2. -12y minus 18y is -30y. -52 plus 2 is -50. Dividing both sides by -30, I get y equals 5/3. Yes, that's a fraction, but don't panic. Plugging that into the top equation, I get 3x plus 6y, which is 5/3, equals 26. So 3x plus 6 times 5/3, which is 10, equals 26. Subtracting 10 from both sides, 3x equals 26 minus 10, which is 16. Dividing both sides by 3, x equals 16/3. So my solution, x equals 16/3, y equals 5/3. So I have the ordered pair 16/3, comma 5/3. Number 6. I would have to multiply to get rid of the x's. This one by -8 and this one by 5. So let's go do that. Multiplying the first equation by -8 and the second equation by 5. I would get -40x plus 48y equals -16. I would get positive 40x minus 25y equals 20. 4 times 5. X's are gone. 48y minus 25y is 23y equals -16 plus 20 is 4. Dividing both sides by 23, I get y equals 4/23. Plugging that number in for y to into one of the two equations, doesn't matter which one. I'm going to go to the first one. 5x minus 6y, which is 4/23, equals 2. 5x minus 24/23 equals 2. I'm going to add 20 thirds to both sides. So 5x equals 2 plus 24 20-thirds is 70 20-thirds. Now I want to divide both sides by 5. X equals 70 over 23 divided by 5. So that number divided by 5 is 14 20-thirds. My answer, there's my X, there's my Y. So 14 20-thirds, comma, 4 20-thirds. Number 7. If I want to get rid of the x's, I would need to multiply the top equation by 5. That would give me 10x on top and negative 10x on bottom. So let's multiply this equation by 5. 10x plus 5y equals negative 15. Leaving the second equation alone, negative 10x minus 5y equals 5. I did that so that I could eliminate the x's. Uh-oh. 5y minus 5y is 0. Negative 15 plus 5 is negative 10. That is not a true statement. 0 does not equal negative 10. So there is no solution. We say that the system is inconsistent. No solution means inconsistent. Number 8. If I wanted to eliminate the x's, I would need to multiply the top one by negative 3, and that would give me positive 15x. Oh, sorry. I want to multiply it by just 3 to give me negative 15x plus 15x. Okay, multiplying the top equation by 3 gives me negative 15x plus 12y equals 24. Leaving the second equation alone, 15x minus 12y equals negative 24. I did that to get rid of my x's. Uh-oh. 12y minus 12y is 0. 24 minus 24 is also 0. 0 does equal 0. So this means that there are infinitely many solutions. Infinitely many solutions. The equations are going to be dependent, and the solution set, let's go pick one, negative 5x plus 4y equals 8. It's the set of all xy that satisfy that equation. Okay, first thing I notice is that second equation is not in standard form. So I need to go mess with that first. Here we go. I would get negative 10x plus 30 equals 25y. All I did was distribute. Okay, I'm going to subtract 25y from both sides. And I would get negative 10x minus 25y minus 30 equals 0. Then add 30 to both sides. And I would get negative 10x minus 25y equals 30. So instead of writing this equation here, I'm going to write it as negative 10x minus 25y equals 30. Oh, wait a minute. No. Sorry. Let me go back. Look at what I did right here. I wrote minus 30. That should have been a plus 30. Sorry about that. Erase. Start back over. Okay, plus 30 equals 0. Now subtract 30 from both sides. I apologize. I'm multitasking this morning and I'm not paying attention to my arithmetic. Okay, my equation should be negative 10x minus 25y equals negative 30. There we go. Okay, negative 10x minus 25y equals negative 30. I'm not even going to look at that equation anymore. Okay, I want to go eliminate my x's. If I eliminate the x's, I need to multiply that top equation by negative 5 to get 10x and minus 10x. All right, if I multiply this one by negative 5, I would get 10x plus 25y equals 0. Leave that bottom equation alone. Add the equations together. I already eliminated my x's. 25y minus 25y is 0. 0 minus 30 is negative 30. 0 does not equal negative 30, so I have no solution, which means the lines are parallel. Let's see, no solution. The system is inconsistent. Number 10, it says to solve the system by either the addition method or the substitution method. I'm going to opt for the substitution method because this one is almost in the right form. All I need to do is divide everything by negative 1. That would leave me with y equals negative 5x minus 15. So that's what y equals. So over here, I'm going to plug in, instead of putting y, I'm going to put negative 5x minus 15. So I get negative 4x minus 3, here comes my y, negative 5x minus 15, and that's supposed to equal 12. So if I distribute that negative 3, I get negative 4x plus 15x plus 45 equals 12. Combining like terms, negative 4x plus 15x is 11x. 11x plus 45 equals 12. Subtracting 45 from both sides, 11x equals 12 minus 45, which is negative 33. Dividing both sides by 11, I get x equals negative 33 over 11 is negative 3. I'm going to plug that x value in and get y equals negative 5 times negative 3 minus 15. Negative 5 times negative 3 is 15. 15 minus 15 is 0. So my x value is negative 3. My y value is 0. I have one solution, and it's negative 3, 0. Number 11. I look at the y's, negative 0.1y, positive 0.1y. I'm just going to add these together. Those are gone. 0.1x plus 0.1x. 0.1 plus 0.1 is 0.2x. That equals 0.7 plus 0.4, which is 1.1. Dividing both sides by 0.2, I get x equals 1.1 divided by 0.2, which is 5.5. If I plug 5.5 in for x, I get 0.1 times 5.5 minus 0.1y equals 0.7. 0.1 times 5.5 is 0.55 minus 0.1y equals 0.7. Subtracting 0.55 from both sides, negative 0.1y equals 0.7 minus 0.55 is 0.15. Dividing both sides by negative 0.1, y equals 0.15 divided by negative 0.1, negative 1.5. So I have one solution, x is 5.5, y is negative 1.5. So one solution, which is the ordered pair 5.5, comma, negative 1.5. Okay, one thing to point out on that last question, it said that I could leave the numbers as integers or decimals. So I chose decimals. And on this next question, it says as integers or simplified fractions. And I noticed I wanted to say something because this problem had fractions to begin with. A better answer is going to be in fractions, whereas this one had decimals to begin with. So decimals were okay in our answer. Okay, so for question 12, seeing that there are fractions, we can leave them alone, or I can clear the fractions. I don't know if you remember that from one of the chapters back on exam 1. If I multiplied everything in equation 1 by the common denominator of 2, watch what happens. 2 times negative 1/2 y would leave me with negative y. 2 times negative 1/2 x would leave me with negative x. And 2 times negative 7/2 would leave me with minus 7. Now I have an equation that has no fractions. Okay, the second equation, if I do the same thing, but this time the common denominator would be a 4. So 4 times 3/2 x would be 6x. 4 times 3/2 would be plus 6. 4 times negative 3/4 y would be negative 3y. Okay, next thing I notice is that these are not in standard form. To get the first equation into standard form, I need to add x to both sides. So that first equation becomes x minus y equals negative 7. The second equation, I need to add 3y to both sides, and then I need to subtract 6 from both sides. So that second equation becomes 6x plus 3y equals negative 6. Now, if I want to eliminate the x's, I have a 1x and a 6x, so I need to multiply this equation by negative 6 to get the x's to eliminate. So here we go. The first equation becomes negative 6x plus 6y equals 42. And then I still have the second equation here. So here we go. X's are gone. 3y plus 6y is 9y. Negative 6 plus 42 is 36. dividing both sides by 9, y equals 36 divided by 9 is 4. If y is 4, let's go plug it into, let's see, that equation. Negative y, so negative 4, equals negative x minus 7. Add 7 to both sides. Negative 4 plus 7 is negative 3, is 3, equals negative x. Now dividing by negative 1, I get negative 3 equals x. So my solution, x equals negative 3, y equals 4. There's one solution, and it is the ordered pair negative 3, 4. Number 13, I'm thinking that substitution is best because I have the first one is x equals. So I'm going to plug what x equals in for x on my second equation. So 10x is negative 1/5 y plus 13 plus 2y is equal to 15. Now distributing the 10 out front. 10 times negative 1/5 y is negative 2y. 10 times 13 is 130. Plus 2y equals 15. Collecting like terms on the left-hand side of the equal sign. Negative 2y plus 2y, those are gone, that's 0. So I'm left with 130 equals 15. 130 does not equal 15. This is not true. It's not a true statement. 130 equals 15. So there is no solution. Okay, the system has no solution. Number 14. Okay, the first one looks to be in standard form, but not the second one. So what do I need to do to make it in standard form? I need to subtract 8b from both sides. That's gone. And I need to subtract 35 from both sides. Okay, I have negative 10a minus 8b equals 19 minus 35, which is negative 16. Okay, my first equation is negative 5a minus 4b equals negative 8. If I want to eliminate the a's, I have negative 10a. How would I make this into a positive 10a? I would need to multiply everything by negative 2. Okay, that would give me 10a plus 8b equals 16. The a's would be eliminated. 8b minus 8b is 0. 16 minus 16 is 0. That is a true statement, so there are going to be infinitely many solutions. This is a consistent system with dependent equations. They don't want all that information. There's infinitely many solutions, and they are of the form all a's and ordered pairs AB such that, let's just put the top equation, negative 5a minus 4b equals negative 8. Okay, here's a word problem. Last question, number 15. Set up a system of linear equations, then solve for the indicated quantities. 3 times the smaller of two numbers plus 6 times the larger of two numbers is 21. Okay, before I even go there, I'm going to let x be the smaller of the two numbers and y be the bigger of the two numbers. For the first equation, 3 times the smaller, so that's 3x, plus 6 times the larger, So plus 6y is 21. Okay, for the second equation, 9 times the smaller number minus 6 times the larger number is negative 33. Oh, hold on. Let me write that again, but line it up better. 9 times the smaller minus 6 times the larger is negative 33. I have exactly what I need to eliminate the y's. 3x plus 9x is 12x. 21 minus 33 is negative 12. Dividing both sides by 12, I find that x is equal to negative 12 divided by 12 is negative 1. So the smaller number is negative 1. How do I find the larger number? I'm going to plug that in to one of the two equations. So 3 times negative 1 plus 6y is supposed to be 21. Negative 3 plus 6y equals 21. Add 3 to both sides. So 6y equals 21 plus 3 is 24. Dividing both sides by 6, I get y equals 24 over 6, which is 4. Okay, let's see what all they wanted. For the red equation, the system was 3x plus 6y equals 21. And for that purple equation, I got 9x minus 6y equals negative 33. The smaller number was negative 1, and the larger number was 4.